Well, welcome 2016. It's pretty scary. I know I may look young, but I'm not as young. But I'll tell you, even just saying 2016 is scary for us older people who are older. In our group, I'm still below the average mean, but I want to welcome everybody. I think 2016 is going to be an awesome year here for the CNPS. I know there's several books in the making, and several books have come out recently, and I encourage everybody to not only become a member, but the membership brings a lot of privileges and good things you can do, which is the blog articles. So if you are a paying member, you can write your own blog. We send those out to over 1,000 scientists worldwide, and like I said, we get 250 real reads, which translates into doubling that, because not all the software can detect them. So I'm estimating 500 to 600 people read the email blast that comes, and then people will click on your articles. And I do see articles like Harry. I see people reading your articles. You at least have 30 or 40 people reading those. So, that's one of the privileges. The other privilege now too is this system, which if you plan to publish anything anywhere, I'm going to try to convince you you're crazy not to use this system, and we'll talk about that. And of course, we have our conference in 2016 coming up in July at the University of Maryland. I've talked with them. I think I've got everything pretty much set up, the rooms and everything already. You can do this so easy long distance. So please think about it. And if you have a paper for the conference, you'll be using this system. It's better than Word, but I'll talk all about that. But again, thanks so much for everybody's support. Our voting has stopped as of 2 days ago, and we had the election of the 8 people for the 8 positions. They were almost unanimous of picking. There was 1 or 2 people who only cherry picked a few people, but in general, I think we had quite a number of people, the paying members, respond. So I'm going to mute people here a little bit. So we've got some breathing there. Okay, so let's go forward. Today I'm going to be working with a ShareLatex. When my dad and I decided to write our book, which we hope to be done in before the conference, I was looking for an online collaborative book editing system, and I ran across ShareLatex, and I was blown away. Me, obviously, being a computer person, an interface person, a web person, I knew exactly what this was. And my father and I have been using it, and it's been really great. And I'm going to tell you why this is a great system today. Um, why aren't we seeing the titles? Okay, that's weird. We're not seeing any of the titles. Oh, wait a minute. That's because I got you out of. Oh, there we go. I'm dumb. I had. I was watching everybody at the top. It was my fault. There. It is. Okay. The previous system we've used was hell for us. Um, Word, which is not free of charge. That means to be in our system for our proceedings for the CNPS, you had to go and find a computer with Word on it. Word does run on Macs, but not very many people have that for Macs. You also get a Word template from us, and you got that, and we have it styled. And of course, in Word, you get what I call style hell. Microsoft's goal in life is not to is the opposite of Apple's. It's design systems as difficult as they can, as clashing as they can, because they get most of their money from certifying people. So I'm a certified expert in this, and so the programmers pay thousands, if not tens of thousands of dollars, which generates billions of dollars for Microsoft, and they make all kinds of products that are not supposedly for the average person, but don't, very opposite of Apple, and you end up with style hell. What happens, we send out a template, which probably is not a clean template, meaning we've changed a style on top of a style on top of a style. So if you were to look at the internal structure of that file that generates that word, it's probably a hellacious piece of text in there. the text markup language. And when a person like yourself is using this, and even when we use it and we're pretty good experts at words, it's still a problem. We get styles and things that are formatted wrong. We can't get it out of it. We'll literally have to sometimes take entire papers from people we receive, that those Word documents, and redo them, literally cut and paste them, text back into a better Word template, because the poor people out there who are trying to use this are not experts at styling. They're mostly scientists. They're not software people, and they're certainly not publishers or graphics artists or anything like that. And if you want to ask, the biggest problem in time spent that Greg Volk spent and myself spent were on this problem. We couldn't have, and there's a lot of intrinsic problems with that. The equation, they have an equation editor. It's not the best. It's pretty intuitive, but again, it's a little bit frustrating, because I think not all, I think the newer forms of Word all have that now. It didn't used to. For the book bosses, again, it is very time consumer, and Word is horrible for the proceedings. When you take a book like this big, 700 pages, we had to divide up the Word document into pieces, get the page numbering correct, and then after that, generate a PDF that we could send to Lulu, because Word doesn't embed fonts. Fonts are the text that you have. And believe me, if it wasn't for one of my aspects of computer science is I'm pretty fast. Even in my fast mode, it was still horrific. And it just couldn't go on like this. It was an impossibility. We didn't have a lot of volunteers to help out, so that just didn't work. Also, the table of contents, a problem. I tried to generate a system with our online system for proceedings. That also was hard. In fact, I programmed probably about 200 hours into at least for the proceedings software that's proprietary, but we're going to be able to use this new system. The table of contents is generated by hand. Like I said, we had no index ever, and now we can. And we didn't have any type of professional publishing system. This is not a professional. If you go to the AAA, guess what language they use? Latex. You want to put your get your paper into the right format? Latex. Okay, we'll talk about that. And of course, it's non-transfer to other systems, because all we had were PDF files. So that pretty much describes that. Shared latex, the advantage, it's on any computer. You don't need to have Word in any browser. There's no program needed. It's free in the sense of it costs you nothing. It does cost you nothing if you want. You open up, all you have to do is register, and you get free ability to use it, but it's limited, of course. If you are a paid member of the CNPS, you get that. We pay a monthly fee for this for unlimited number of people. And so you will have the ability to use that to your heart's content. We are sharing it. So the rule is going to be is we're going to have a lot of folders for a lot of people. So hopefully then let's see, mute him. There we go. Hopefully, we'll keep that. We can put things in folders. I asked the people who are the people in the UK who started this. I've sent them direct emails to the software engineers who do this shared latex, and says, hey guys, you got to be a little bit better for especially like proceedings. You really got to do something great with that. And they said they have nothing in the future for that. I'll talk a little bit later about that too. It's collaborative. It's called ShareLatex, and that's the key. That's what makes this so great. And actually, the editor is really good. My father's been using it. My father's an electrical engineer. He's a hardware guy. So if a hardware guy can do it, any living creature can do it. So he's electrical engineer. Uh, Based on latex industry publishing standard. Latex is, and text itself. Latex is an interface to that, but TEX and latex are the way books are published around the world, period. This is the language they use, period. There is not another one. So we'll be putting ourselves up a bunch of notches in the world by doing this, and can be treated much more seriously, even though our content sometimes is not. There's no style application in the sense of you style hell. I should have put really there. That is, it's not something you put on top and say, now it's bold. You do something similar, but it will never be, it's all transparent because it's a markup language. A markup language means when you look at it, yes, if you want something in italics, you're going to have something around that that doesn't show up at like an HTML, but we know what it is there. The style problem is the style is hidden underneath in the doc file for Word, and you can't get at it. And well, you can if you have to be a super expert hacker. I mean, I can get in there and see that, but that's what the problem is. If you put a style on top of a style on top of a style, or a style gets screwed up, what happens all the time in Word, sometimes you can't get out of it. I know many of you come to that problem with these Word templates that we give you. You can't get it to the style you want, it won't go there. That's because there's an error in the markup language underneath. The equation notation is built into the language. This is the language they use to make those beautiful equations for all the math and textbooks. Period. That's what they use. So we're going to be using that. It's pretty easy to use. We'll show you some of that today. It allows for drawing graphics. The book from my father and I's book, my dad drew a bunch of graphics in Word. They were real pixelated. They weren't very nice looking when they got to the publisher. I'm going to show you that. You can put embed graphics, and you can literally draw. Most of the diagrams you see in books that are drawn, that are more scientific, circles and lines and graphs and math equation, all that kind of stuff, it's done with what's called TIKZ, T-I-K-Z. Shared bibliography file. It uses the common bibliography files of all the systems. What does that mean? That means if you have bibliographies, you don't have to cut and paste those from places. That's all. And all better than that, and this is the big kicker, it auto calculates equation numbers, figure numbers, and the bibliography. All you have to do is cite, put the name of the thing from your bibliography file, it generates it, and that's it. It auto-generates for the proceedings, table of contents, references, bibliography, and index. I'm going to be checking on the bibliography for the whole book. I'm not sure about that, but an index. That means in our proceedings, you're going to be able to mark an index, and that will be indexed, and you can call it whatever you want. It'll show up in the index at the end of the proceedings book. Pretty phenomenal. Okay, this is the interface. The LaTeX evolved. This is what you saw in the beginning. I'm not going to start here exactly, but I just wanted to show you. When you get into it, you're going to get into a folder, or your project, it's called. In there, you're going to have folders for stuff. We'll talk about that, but this is basically like a bunch of files. It's online. This is the cloud. All the cloud means is instead of having everything stored on your computer, you have everything stored on their servers, and you access it via the internet. And that's what this is their home page. In the middle, you have their editor for LaTeX, which is really great. And right next to it, you get an instant feedback on how it looks. It's quite phenomenal, and you can download it at any time. You can literally click on a button, and if you want to have a PDF version, you can do that. I've edited this on an iPad, so it means no matter where you are, you could be somewhere, don't even take your computer. All you have to do is log in as you, ask somebody to use their computer, and you can be working on your book, your paper, whatever. And again, if you are planning to write a book, or planning to write a paper, even not for this group, but for another group, you can use a system. If you're a member of the CNPS, you get a free unlimited system. Okay, the LaTeX language, it's short for Lamport Text. TEX is the text publishing language. It's really a word processor and document markup language. Again, that means you have in it, if you have something bold, you'll say \text B for bold, curly brackets, and in there's bold. What that means is there's no hidden anything. Everything is there. So you don't have no worries about that. It also means if you put an index mark, it has a whole system that goes through and finds all the indexes and makes the index page for everybody automatically. So these are great things. It's distinguished from a typical word processor such as Microsoft Word, LibreOffice Writer, Apple Pages, Opens Office, that kind of thing. LaTeX is used for, and this is from Wikipedia, LaTeX is used for the communication and publication of scientific documents in many fields, including mathematics, physics, computer science, statistics, economics, and political science. I don't even want to waste time explaining why this is good for us. Here we go. I came up with a template for the CNPS. There are templates in ShareLatex, which I have a great set of LaTeX templates, and I chose one that was close to what we do in the CNPS. And this is going to show you how easy this is compared to formatting. Okay, we're going to take a look at this first one, which is actually a abstract from the last conference I happened to just put over into the system. Took me about 40 minutes, 45 minutes for me to take the Word document and move it over to this system. But in doing so, it came out way better than the Word document, and I'll show you why. So CNPS, I can't remember what the document was. It was for one of the conferences out there. So I took their LaTeX template, which is what we will give to other people who have never been here. And there are places that actually list these templates. I still have to work on it. It's not been easy because I'm doing a lot of programming that isn't available out there for Proceedings, which doesn't exist. The Proceeding stuff they have is pretty bad. But anyways, this template is going to be there, and this is what people are going to use. So let's just take a look at this page here. Why is this really, really great? Well, first of all, abstract, you don't have to worry about, is it indented? Where does it go? What font is it in? You don't care about that anymore. This is all literally just text. That's all this is. I don't know if you can see me highlighting. People, can you see the highlighting? Maybe not. I highlighted some text in the chat. Anyways, you see here, let's start at the top, keywords, gravity, light, mass. Author, again, what you see is a backslash and what I put in blue here. What I put in blue is the markup language. HTML for the internet is a markup language. If you want something bold in markup language, you put a angle bracket B, the word, angle bracket backslash B, enclose, and that's what you get. Well, LaTeX has its language. It's actually more primitive than HTML because HTML is in its iteration 5, I believe. This hasn't evolved a lot because it really doesn't need to be. They did a lot of it in the beginning. But anyways, you have keywords. You can see how it's done. You just type in between the curly brackets. You don't change keywords to a different word. Obviously, I hope you realize that. All this format, you can't mess around with the curly brackets and those things. But all you have to do is put the author, and then after that, you see a little open curly bracket, Robert E. Hilster, close curly bracket. You have, again, I don't know if anybody can see me highlighting, probably not, but you can see the address here. The address is, you put in curly brackets. Those curly brackets tell everybody this is part of the author information. So all I do is put the address in there, put a comma and I put the email. Same way with me. I've got 2 of them. If I have 3 of them, I copy the same thing, put them in. Inspections, it should be what we call intuitively obvious to the casual observer that you do by inspection. You do and copy the same thing. What normally happens in these systems is that what happens is if you make an error and then you try to compile it, that is, okay, I want to generate the document. So let's see how it goes. I literally generate the document as many as 4 times in a minute because I want to keep seeing this. And this will generate, in fact, in 10 seconds will generate an 885 page book. So it's a fast compiler. So what you do is you'll find out that you missed a curly bracket or something, you didn't cut and paste it right. You'll get error messages off the side. I'll show that during our live session. But here's the abstract. Again, notice here also in the abstract, if you look there, it says index light, index light. You notice that there's a backslash index after the word light in the first line of the abstract in the paragraph. Well, what that is literally an index. You don't see that. When you compile, that will be gone. That won't exist. Abstract won't be there. None of this will be here. So that's how you index. What you do is right after the word or phrase, you put a curly bracket and you can put whatever you want in there. Of course, if you put 74 words, that doesn't make sense. Index should be pretty small. So that what that means is that for the proceedings, we're going to get an index generated, and your stuff indexed in your paper will be in that index. Okay, and then you notice at the very bottom, I just want to point out here, there's a thing called make title at the very bottom. You notice there's nothing there. Well, what make title is a program, is a function in LaTeX, which is triggered to then make all this stuff look pretty. So what you're doing actually with LaTeX is you're telling it, this is the abstract text, this is the author, this is another author, these are the keywords. You're not telling it where to put it or how to put it, okay? That's not this part, that's not the main body. So this is called the title page. That's all gonna be done. Let's take a look at what that looks like. That's what that generates. It's pretty phenomenal. Let me show you a couple things that's really phenomenal about this. See, Robert D. Hilscher has an asterisk, and it comes down here, and it matches him up to this line. David D. Hilscher, I have a dagger there. That dagger matches me up with my line. I didn't do that. You don't have to do that. Look where I put the keywords. Put the keywords down here, put the title up here. With this side, it justifies it. You can notice looks very similar to what we did in ours. Well, that's the power of this system. This is why this is so much easier. You don't have to give a about formatting. You're going to do very little formatting in the system compared to the other. There's only going to be a couple things you're going to have to deal with. And that is phenomenal. Again, let's go back and look at this. What this is just information. It's not formatted, and it comes out to be pretty like this. And if you put another author, it's going to get this. It'll say Robert D. Hilscher, comma, David D. Hilscher, comma, Nick Percival. It even glums them together with conjunctions, as we call linguistically the conjunctions, correctly. And it'll put more things down here. It probably won't do neutrino papers or Higgs particle papers where you actually have 935 authors, although it may do that, but that's a different story. That's sad about our modern physics, another thing. Okay, let's get to the introductions and all that, and main part of the paper. So after that, you're going to do this thing in which I call CNPS heading / section, and then you say, here's a heading, applying theory. Okay, and then let's say you wanted a subsection. Well, you do just CNPS heading / subsection light and gravity. In LaTeX, in shared LaTeX, you don't have CNPS heading before the select section. I have made that function in my particular coding. The reason I do that is to create a table of contents for all the papers when we put them all into one folder. So we're going to have a folder for the proceedings, which is going to have all your papers. I'm going to copy your LaTeX file over into my proceedings folder, and we're going to just keep generating it. The proceedings, I don't have to generate the table of contents, nothing like that. But the only way to do that is I had to modify and add a function to that. So you're going to see that when you go into ShareLatex, you log in, you register, you go in, you make your you get in there, and you're allowed to, at that point, you have they give you free use of it. That's how they get people like us to use it. So you can start messing around. You can try papers. You're going to see section, subsection, not CNPS heading section, CSP heading subsection, etc. So the reason we have those is because I've done programming for our particular papers and our particular proceedings. So that's pretty precarious in some sense because it's the first time I've done it. It's very hard. I've talked to people all over the world. There seems to be a few experts who do it, and I think to have a programmer do this, it could cost us anywhere from $5,000 to $10,000 to get ourselves a programmer in LaTeX who is super expert to get exactly the proceedings format we need. Of course, if you're the AAAS, you've got, hundreds of thousands of members. Yeah, you can afford 10 grand. That's not much, but 10 grand, heck, that's some money for us. So here you see applying the theory. And then, of course, you just see a paragraph after that. There's a place called Document Start Text. I didn't show that. Should have shown that. It should say begin curly bracket document, end curly bracket, and that's where you start your paper. In between the begin document and end document is going to be your paper. But I'm going to show you and highlight some of these things here. You notice that here you see the applying theory. It's 5.1, 5, and then 5.1.1, lighting and gravity, and you can see it coming here. You also see that it's in 2 columns. That's because, again, the template I have, you don't write in 2 columns. You don't have to worry about 2 columns. It does it on its own. You're just going to see one thing. You don't see 2 columns here. Of course, we didn't in the other either. In Word makes it flow, but my gosh, it was harrowing at times to watch those columns get screwed up and stuff. So that will be generated. You'll just keep compiling those. Okay. Here's an example of equation. Frequency, wave, length, and velocity. Here you see the subsection. You can see that here, 4.2. The frequency of the particles determined blah, 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 and designated by, and you see up here in this blue section here, $V underscore P $. Well, it turns out that in LaTeX, if you want to include mathematical notation language, or equation language, you do that by offsetting a $. So if you have a $, let's say in your paper, you're not I don't know if many of our papers even have a $signs because of our subject area. If you don't put a backslash in front of a $, it's going to assume that you're looking at a mathematical equation. Again, this was written more for technical publication, so they make it as easy as possible. If you want to say, I earned $1,000 and you want the $, you just put a backslash in front of it to say, hey, don't treat this as a function, treat it as a $. So V, you have V, and then if you look down here below it, you're going to see V underscore P. You're also going to see V in italics. So LaTeX has the ability to make equations have their own font, meaning a different font to distinguish it from regular text. So that's how you would include it. And you can include anything you want. You can put a full-blown integral summation in there if you want. Normally you don't want to do that, but you can. I've got papers that actually have people doing huge equations in there, but you can do it. But if you want to do equation, you notice you come down to the middle part here. Over here it says begin equation. You see a thing called label. Labels are very important because they correspond to references. If you look right above it, you're going to see reference, equation, V, plam, D, DAW. That's just what I do is normally I just abbreviate the entire, I should have put an F in there, FVP. I take the equation and just write off the letters and it gives me a unique name. You want to make a unique name for your label. You can make it in English. Just make it my favorite equation today. And then you put in the ref, you'll just say curly brackets, put my equation today. Well, what happens, that label then comes down, if you look at the bottom, says, you'll see an equation and then it says ref equal F for frequency. But if you come down into the generated text, which is below it, you'll see it says in equation 5. Well, this is the thing that makes it so wonderful. Let's say I want to put another equation and you put it in the very beginning. What happened in Word? We had people that this happened to. They had literally 50 equations. You insert one in the beginning, you got to renumber all those equations. So then they put some, funny number in there to do that. You don't have to do that ever. In fact, you can put a ref in there. You can also put a page ref. If I were to say in equation under \ref, give it its name, its label, and then I say on page, I say backslash page ref, it'll literally go and find the page on it. And then in the text, it'll say, you'll see in equation 5 on page 23, pretty amazing. That's the thing, that's the power of LaTeX. Okay, let's look at the equation itself. We have F equals fraction. You see the fraction has a set of curly brackets with something in it. So in the notation for LaTeX, curly brackets mean contained entities. So you're saying a fraction of V underscore P over lambda underscore W. And you see fraction has those two things. If you don't put those two things, the compiler will complain and yell at you and try to point out where your mistake is, okay? But you see down here, then I get an equation with equals VP over lambda W. This goes on and on. I'll show you a more complicated one next. But you notice again, it labels things automatically. It keeps track of where they are. Pretty phenomenal. Equations, more complicated. This is again from the text, the top part there is the LaTeX. The part at the bottom that looks pretty is the compiled part of LaTeX. So you say the obtaining equation, then blah, blah, blah. This is from I think that my dad's book or our book or both. You have equation. You notice it has, again, equation blah, blah, blah. Well, it turns out here, equation 5.5, you notice that it says 5.5. Now, you also notice this is more complicated. You have F, now you have a sum. You have a backslash sum underscore, and then you have the two curly brackets followed by an uptick, meaning the underscore means this goes below. This little pointer up there means it's going above, which is 180. And then you have a sum, another sum, and you go on. I want to point out a few things here. Underscores obviously mean subscripts, and then things that are, I don't have any superscripts here, but superscripts are done with the up caret, which is above the 6 key. Okay, and so what you have is more than that is you have parentheses. If you look in this one, you're going to see a backslash BIG in front of a angle bracket, what we call an angle bracket. Oh, no, I'm sorry, square bracket. Sorry, wrong terminology. So you have the summation F equals M, and the summation from one summation and another summation, and then you have a big square bracket. And that square bracket, if you don't put big in front of it, it'll be small. There are times where you visually want to say, no, I want to make this more obvious. And there's actually a bunch of notations. There's backslash small BIG, backslash capital B, small IG. There's literally backslash small BIGG. So there's big, and it's many forms of how the spelling and in its capitalization. Those will get you bigger and smaller. ShareLatex has a great help on all that. You can take a look at that. Okay, but that gives an example of a more, you can do integrals are very similar to sums, those kinds of things. The other thing we have is bibliography file. That's really great because what does it mean? Once you write a biography file, these are standard bio files. I can't remember what they're called. There's bibliotext or something like that. These are pretty standard. You can import them if you already have them. ShareLatex will import the most standard bibliography files. We're going to keep one for the CNPS, and we're going to just keep growing it. What that means is if you include it, it doesn't matter if you use them all. You just have this big file sitting there, and if you access the name, so let's say the first one's article Wang Eclipse, so you have Wang-Eclipse, that has to be a unique name. Book Borker-Assumptions for his 10 assumptions of science. Online, there's also miscellaneous. There's many more forms of this, journals, that kind of thing. But we have 3 of them here, article, book, and online. Those are the most common. So the online has its author, the title, the URL, and the keywords. Keywords aren't used, but I think it's used in other systems and can be used in different ways. I just put them in there just because if we need to use them for that, it's there. But right now, we're not using the keywords in the bibliography file. This is how you do your bibliographies. Again, what makes this nice is that you don't have to format jack. Nothing. Zero. You don't have to worry about what the number is. You don't know about generating at the end. You don't have to, guys, this is so much easier. You're nuts to use something else. I'll never use Word again for these kinds of publications. Let's take a look at what happens here. This is from our paper, this metals, magnetic fields, and electricity. You notice here it says Yunel Deneu's underwater cylinder experiments, open square bracket 1, close square bracket. I didn't do that. If we go back here, you'll notice in this, I have a, oh, I don't have that. I don't have this at all. Where's the, oh, bad slide. This is a site. I'll show you this. I'll correct these slides. But what should happen here is I should have showed you over here the latex. But right here is a thing called \cite, C-I-T-E, open curly bracket. And then in that open curly bracket, whoops, I would put in here Deneu underwater, Deneu dash underwater dash cylinders, closed angle curly bracket. That's what I would put in the latex text. It will generate this, and you notice down here, it generates Yunel Deneu unraveling. Well, I don't think that was the one I got. There's another one. Okay, again, bad example because I don't have that. But this comes from the Bib. I didn't do anything. These references here are completely generated automatically. The numbers are, so if you add more references, you just add the site anywhere you want and put the right name in it. It'll put the number in and it'll appear in your reference. You add, if I go in there and add a site to someplace else, it'll automatically appear in the references, renumber everything. Just fantastic. Bad slide, shame on me. Okay, drawing. Drawing is also nice. And I will tell you, with my father's first book, which we're working on the second edition, I'll show you here some of this stuff. Great book, by the way. I'm finally learning what my father's doing, but I'm gonna try to find you one that's sort of jaggedy. But yeah, here's some. And what happens is, if you look at these, those are really jagged. That is, when you look at them close up, they've got little pixels and they're pixelated, and they don't look professional in the sense of the graphics themselves. That's a problem, you know. And to give you another example here in this book, using word equations like this one right here, that's actually a graphic, because at the time he was doing this, you know, it probably wasn't working out trying to get this whole thing together in a book. That's now gone. There's a package called TIKZ, T-I-K-Z. I won't get into it. Oh no, not yet, Dad. Hold on.
First drawing this morning. All I want to say is I did my first one this morning. First one.
Wow. Really?
Yes.
Did you use a grid?
Well, I did a circle like is shown. I got 2 arrows and 2 words in this simple drawing I did. And it will go in my second edition of the book. So I'm going to start taking that away from you if I can.
I'm still going to go in and make it look prettier, probably.
Oh, come on. Goodbye.
Because I'm an artist, you know, and I don't like, I'm giving you a hard time. But if my dad can do it, and he's an electrical engineer, it's proof that anybody can learn. Thanks, Dad. Wow, that's pretty impressive. And actually, there's a way to do that. And for those who want a more in-depth tutorial, hopefully we'll show that today as well. Here we go. Let's look at this. And this is called Begin TIKZ Picture. And in here, you're going to see, here's what it's going to generate. See, here's the particle interaction, and you have some stuff here. And I'm going to show you, I think, some of the, yeah, you'll see sort of how that's done. Let's not concentrate. This is in its own file. I'll talk about that later. But this is a figure. Again, LaTeX does all this stuff. You don't have to number the figure. You don't have to format anything. It just goes there. So let's take a look at some of how the drawing is. It's pretty easy. A fill draw is I fill it with black. It's a circle of 0.07 centimeters in radius. So you see that circle here. this size, you see circle down further, 0.07 radius, and you see circle 0.7 radius. This first one will draw emitted. You see the word emitted. The first line draws a circle and it's all on a grid. So it's you go minus 2.04. Again, that just means in your head you have to do a grid, but I have a way to draw that grid, which I'm going to show you. I don't have it in this, and I should probably put that in here too, but I will show you that later on. I usually draw a grid that I see, and then I can just use my mouse and say, okay, I want that there, and I keep that grid on until I'm done, and then I comment that grid out. But here you see, put a circle there. Emitted is a node. That means it's just a place. You notice I put it at minus 2 and 0.07. I draw a line from here to here to here. So you have an XY dash dash, XY dash dash, XY. There you go. The second one, then you see a V. I put a V down below, again, using coordinates. A node at XY, and in the curly brackets, I put the V. If you want to put a whole equation in there, you can do that. You put dollar signs in there for the equation. Then I have a node circle. It's a draw. I fill it with blue. I lighten it up. I don't have a solid blue, so I have a bang 25 blue. Bang is an exclamation point, 25. Again, you just use the examples they give you. If you want to change it to red, change it to red. You want the blue darker, you change it to 90, change it to 100, it's 100% blue. The minimum size, that's just the way I did this, and then I put water. You notice this is a node, so you can make this water, I didn't tell where to put it, it puts it right in the middle. So the center of my graph, I made the middle where this circle is. So you notice the circle, the blue circle, 0, 0 is right where that circle is. It's the center of that circle. You notice above that where you have like the word emitted, you have a -2. Well, you go X direction -2 to draw it. I mean, it sounds like, oh my gosh, no, it's great because it generates encapsulated PostScript, which is what people use for publishing books and diagrams. When people get their books published and someone does this, they hire people to write these, make these diagrams as part of it if you want that. You can do it on your own. If my dad can do it, you can do it. Do it, okay? Let's look at some other things here. Using images. Oh, I've got an image, Dave. What do I do? Well, you have to, oh, here's a site in it. Great. I've got a site there. The ref's not there. Okay. Image. What do? You upload the image to a folder, and I'll show you that later in your folder. And then in this case, if you see here, it says paper 1 / Yonel Deneau. Well, I have a folder called paper 1 because I have my own folder. In my own folder, I have another folder for my paper 1. And in paper 1, I keep all my documents and drawings and images. So I put that in there. I upload it by clicking on the upload, finding out my computer, and bum, 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 uploaded. Very, 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 very fast. Now it's there forever until the server blows up. And so you have that there, and you go and you put into this a figure. This is a figure. So I'm showing here not only the image, but how you make figures. Figures are pretty neat. Begin figure. You want it centered, centering. That means it will be centered. Okay. It's a include graphics. Yeah, include graphics. Scale it at 0.05. You just use whatever number. You put in 0.05. That's half. Let's make it half the size. Oh, it's huge. Well, keep making it smaller. Put numbers into until it fits. And then after that, I have the literally file name. You notice I didn't put yoneldeneau.jpg or .jpg or .png. It will accept and look for that name with those .jpn. I think it doesn't like GIFs for some reason, but all the other ones it accepts. Doesn't matter, you find out. You notice down here, I don't say that, it says in figure, ref, figure Yonel Deneau. Now you notice that what that means is if you look over to the right-hand side, you're gonna see shown in figure 4. Well, I didn't number figure 4. All I did was in the begin figure and end figure, I put the label on it, which is Yonel Deneau. I said ref figure Yonel Deneau, and it goes and names it, puts the caption. You can see where the caption is. Again, by inspection, look at the little things, They all make sense. There's nothing there that doesn't make sense. The only thing you have there is an HT. That's just to say, I want to put it in a horizontally and the top. But there, if we'll talk, we get into the mumbo jumbo of that a little bit later, where it puts it on the page. That's what that's for. So that's what's positioning. Like you have a column, you have a page, you have a big diagram. Do you want just that, and it just throws all the text below it? It doesn't fit. It's got to put it on the next page. Do you want it just to cut the text? Those kinds of things. Those are just little things that you don't think of when you're publishing, but it's all automatic. Okay. What do I do? Put this in twice? Oh, no. Oh, okay. I did put it in twice, but that's good because this is the second part, which I thought I didn't have in. So I guess I don't need to put it in. This is to give you an example of how you call it making a figure. Again, you have the section, particle interaction. You have a paragraph and you say figure blah, blah, blah shows this particle. If you look up in the text here, it says figure particles water. This figure colon particle water in the label itself is actually not necessary. The reason you don't need to put figure colon, because the ref doesn't care what it is. It's just what we call common practice in LaTeX to make figures and tables to do that. I even put them for chapters, which a lot of people don't put them, like CH for chapter colon. It's just a naming convention so you know what that's about. Okay, and here again you see start a figure, centering it, same thing. There's the caption, and this time you see not an image file, but another TEX file or LaTeX file. Remember, text is the language. LaTeX is the editor for the language. That's where that came from, just in its origin. But LaTeX today and age is what they use because most systems don't always include some type of editor. ShareLatex is share means on the cloud. LaTeX means we've got an editor for you. So here's the figure. It centers, and you see particle-water.txt. That is the file that we looked at back, oops, too far, here. So this file, as you notice at the top of this, it said drawing using ticks, and I put colon particle-water.txt. That is in the same place my image is. Why? I don't want to necessarily keep all this stuff in the middle of the same file. You can, but practice is normally you don't, because a lot of times you want to use them again. Sometimes you do have them in twice. My dad will do that. He figures if he didn't get it the first time, he'll try another time. Ha. Okay, so that's what this is. That's this text file, and again, this is what is generated. Perfect display. I've got a book, a secret book my dad and I are working on, the particle model of the universe. Here we go. In here, we've got stuff like these diagrams, and you see circles. When I look at them here, even with a magnifying glass, I see no pixelization, zero. It looks super professional. So that's why you want to do it this way, because when you get them, they come out perfect. Okay? Well, all right, there are other things you can do with it. Just to give you an example, the ER scientific documents. So what people have done, programmers in LaTeX have developed what they're called packages. Packages, you'll see those things called / use package and like Feynman. In this case, FMF graphs. That package will allow you to generate Feynman diagrams. This is from Ray, Ray, who is wanting to use this system, and I actually moved his whole paper over. He had a Feynman diagram in here. So this is really fun. Here you can see there is, here's the drawing of the grid, Dad. There's a, you guys, you see this here, you have begin ticks picture, and then you have drawing of the grid. And I should have regenerated that, because what you would see here is over this is a grid, and that grid will be the lines at 0, 0, and 6, 4. That means it's going to be at the bottom right-hand corner, bottom left-hand corner, and then all the other points go from there. So, but in this case, you don't need a grid, but that's what I do when I do drawings. Like Dad, when you did your drawings, if you set up a grid like this, everything's the same. You just set up the 0, 0 point of the grid and its corner. These are actually corners of the grid. And then it'll be there. And then you can like look at it and use your mouse and say, okay, I think I need that word right there. It looks like it's -2 plus 1.8. And then you can put your text there. But here you have a Feynman graph, and it is a package. You say include Feynman graph. You include, it says use package command, squiggly brackets, Feynman graph, and then that's available to you to use. So if you put begin Feynman, okay, and this is 100, 100, that's just sort of a sizing thing. Forget about what that means right now, but you can say, I'm going to start from the left. I'm going to have one on the left. Feynman diagrams, you start out with a number of particles and you end up with a number of other particles. So the Feynman left and right, you have FF, FMF left. I'm going to call one in one, FMF right, out one, out two. If you look at this Feynman diagram to the right, you're going to notice, yeah, I've got a photon coming in, a photon leaving, and then a fermion, what they call fermion, coming out. And then I put, he wanted to draw a dashed line, an arc, and a theta. We put that in. But the Feynman diagram itself, I didn't draw the squiggly line. I didn't tell it where to put the lambda. I didn't tell it where the lambda prive. I didn't put this arrow in. I just said photon, and I put the label on it. I put the label here, question mark. I think is I think it's nothing, or if you just don't put anything, I don't know why that's there. Sorry about that. But it did generate this. So lambda, you notice I put a backslash lambda. That will give us obvious a lambda. And then a prime. And there you go. And I said the first photon goes from I1, which is the left side, to W2, which is the interaction. Then the fermion comes from the interaction to I1, and then the photon goes from the interaction point W1 to O2. So that is a package that's used. Some programmer says, I'm going to make these Feynman diagrams real easy to draw, and I'm going to let everybody use this to do them because all the physics papers that do this are using this. Then afterwards, I just put my draw the dash in there, lines. You notice a dash. It's got an X and then a Y. You put in a dash and square brackets, blang, it goes dashed. So you can see it's pretty darn easy. Electrical circuits, for all you electrical engineers, which I know there's a few out there. So what do you have? There's one called circuitix. So it's tix, circuitix. It's a package. It's available. So I said begin circuitix. And then you see here, to a short, to a battery, to a resistor, to a capacitor, to a capacitor, to short, to a capacitor, node, scale, et cetera, et cetera, et cetera, et cetera, et cetera, et cetera. Okay? That means there's no drawing here except for where I want the wires to go. I want it to go from here to here. And yes, I absolutely drew a grid for this. So I knew I'm going to go from this point to this point to this point, that sort of thing. So you need to have that grid back. Like I said, right here in the previous one, this draw grid, you make the grid the size you want. I always keep step equals 1 in 1 centimeters. It seems to work well. Gray meaning, it should be gray 30, not 0. Oh, that's why. The 0 means I'm not drawing it. I'm drawing white on white. That's why you don't see it over here. That was just to get the picture of it. But if I put this at 30, that gives me a light gray grid where I can then start making my points. So yeah, I had to point to things. So the grid was all the way to 24. So it's pretty big. What does it generate? Wow, pretty darn amazing. Where's all the curly cues and all the lines to make resistors? There are none. I didn't draw those. All I did was make a grid and lay it down. And there you go. So this is from my dad and I's book, I believe, or his first book, or his second, or our book, which is his second book. Okay. All right. Collaboration. This will give you an idea of how collaboration works. This is for Ray Gallucci. Ray Gallucci, I put his paper in there. The file is called AAA-paper because AAA keeps it in alphabetical ordering at the top. So here you can see, you click on the interface, there's a clock going backwards, and it's not reverse time dilation. All it really is basically you can click and see that this time this was changed. When you click on any one of these to the right, you will see who did it and what they changed. And you'll see the blue stuff is addition and the light blue with strike throughs as what has been changed. So this is absolutely great for cooperating on a paper with someone else. You can literally do it at the exact same time. How do you deal with that? Well, you're going to see the person up here. When my father is actually editing something, I will see an R up here for Robert because I share this folder with him, and so he has the ability to edit anything in there. And so I will see. And not only that, you can see what he's changed, what I've changed, what he's changed, what I changed, and when. So when I go in there, I go into the file, for instance, and see it's not compiling. My suspicion is a non-software engineer, probably worse, a electrical or hardware engineer has screwed up the latex and it doesn't compile. And when it doesn't compile, you get an error. So I go in there and fix all the problems. So he knows that. So he says, my son will do it. That's his job anyways. So I'm sure people are laughing. Okay, and so you can see that, and you can actually restore it if you didn't like the changes. Okay, here's the, I'm pretty much done here with this. Just in conclusion of this little talk here, using the CNPS template. Obviously, you can go hog wild and try to learn everything, but the best way to do it is to use the template that I will give you. Where is it? I'll set it up for you. You contact me, and then we'll go from there. But basically, here are the things to remember when you get this template, and they are very important. Only edit your files and leave the others alone. When you get these files, when you I think I can go back here to the page where it has the interface. Sorry, right here. If you look on the left-hand side, you see these things with folders and files and stuff. You're going to see a lot of files that you don't know what the heck they are. Well, I'll tell you what the heck they are. They're the files that Dave DeHilster put together to make our style the way we need it, the things that we need for the proceedings, and those have to stay around. If you go into them, some of them you can't change, which is good. Some of them you can. Go in and change them, screws it up. So only edit your files. The files you should edit are your main text file, which I call AAA-paper. I could call it something else, but that's going to be your main file. You can obviously add to the bibliography file, the .bib file. And of course, you can edit all your .text files that are for drawings that you do. Those are yours. Don't touch anything else. The only edit the paper's content in the main text file. Okay, that's what you want to do with. That's what you're going to be doing with the files that we give you. You don't go into another one called proceedings.txt, which is there as a placeholder so that when you move it to our system, it works together and plays well together. The reason it plays well together is because I spent all those 30, 40, 50 hours writing the code to do that. And so if you go in and change that one, guess what? Your file is looking at that because it's pretending that that's the big proceedings file. And yeah, you can see your table of contents, you can see the index that's generated, and that's there for you to see those things. But if you go in there and change it, it doesn't compile, not good. Okay. Upload your files into your papers folder, obviously. So if you upload an image, you want to do that. Okay. If you have a bibliography and you want to import it, you can do that. Ask me if you want to set up for a new paper or book. Ask me if your paper or book is no compiling. Yes, I speak Spanish from Mexico. If your paper is no compiling, you will have a problem. It's not compiling. So if it isn't and you really can't get it to compile, take a look at the errors if you can. Okay. And then if you are a wizard, please consider helping others. My dad has volunteered to do that because he is actually going, oh, my son's doing a lot of stuff, and maybe I could help. So, but he has actually volunteered to help many times, and most of the time, people who aren't programmers like me are way better people to ask questions to, because I get impatient with stupidity. Of course, I'm not calling anybody stupid. It's just an emotional thing. We're just thinking, it's there. The error code said dash 42 hex bang bang curly brackets. Of course, that means you forgot this here. And of course, it's just helping people all the time with everything. You get jaded. So I'm completely jaded. So, maybe have my dad help. But that actually concludes my talk. The rest now is going to be demonstrations. So instead of taking questions now, I'd rather go to an actual live example of editing to show you sort of how this stuff works. Okay, and unless there's a real objection in something that somebody really thinks they need to speak to me now, that would be fine. And if you're on the phone like you, Duncan, and you can't see any of this, um, that's okay, because I've talked my way through the slides mostly. But I'm still going to record this. This will be recorded, and usually by 1 o'clock this should be on the YouTube channel, so you should be able to see that today. Pretty fast, huh? Okay, so I am going to start sharing. I guess I will see if I can show campaign builder design. Okay, I'm going to try this, folks. See how this works. Okay. Can people see this? It's going to take some time for it to load up.
Dave, I can see the drawing.
Okay, you can? Okay. All right.
So you're sharing your desktop right now.
Yeah, I am. And I don't have, okay, so share latex. Here we go. Oh, is it the whole desktop?
Yes, it's the whole desktop.
Okay, that I need to know. Okay, I'm going to try to keep it at a certain size then. Okay, here is the login. I'm going to log out. I'm going to log in with our admin. Okay, we'll log in there. This is the big account. We have Ray Gallucci and these proceedings folder. Now, what we're going to have each one of you do, because we have so many members and stuff, it's not super well here, meaning once we have 50 members, we're literally going to have 50 things listed here. And yes, I can't change that. I'm not making this interface. It's not necessarily the best interface for super collaboration. It's good for collaboration, but not super collaboration where you have things. It would be better if we could put things underneath there. But for each person who is a paying member of the CNPS, you will have a folder with your name. Everything that you do will go under here. So we're now logging. We've logged in. I can do it as Ray. And here you see the typical setup with the 3 windows. Again, I'm going to try to keep it smaller so that hopefully in the recording it won't look too big. Well, maybe I should make it bigger. Okay, I'll just go ahead. Okay, let's take a first look and just look at what we have. We have over here on the right, the left-hand side, my folder. I'm Ray Gallucci. I have paper 1 and I have paper 2. All this other stuff you do not touch. You don't touch this. You can look at it. This is a zip file, which actually shouldn't be there. Oh, no, that's there because that's the entire template if we want to recover it. And there's a proceedings text that I talk about. This will be what the proceedings text will look like, the TEX file. Text, when I say text, it's TEX, the TEX file. And this is a proceeding text. And here I have, as you notice, if you go down further, you'll see paper 1 and paper 2. I'd put all their papers in here. And this is, again, not to be touched. If you want to add your other paper in there, yeah, you can. That's probably, you can go in here and add paper 3 if you want to see it as if it would appear in the proceedings. But we don't want to see that. It's not a big deal. Okay, pretty much don't touch this stuff. These files are literally it's from the AIP. So this is from the AIP template, uh, American Institute for Physics. I don't know what it is. And I took their programming in LaTeX and I edited it to make it look like our stuff. So if we go over this side, well, I won't get there yet. Okay, get back. Sorry. Don't get off track. Over on the left side, we have paper 1, paper 2. In paper 1 is a real paper. It's got all kinds of stuff. You notice I have AAA-paper.text and AAA-paper1.bib. Well, those are the text files that you're going to be using for your paper. I also have the Compton photo, which is what we've seen, which is a drawing. There's Yonel Deneu's image that I've uploaded. There's a gravity mass. There's another image I didn't use. There's another text file that I have. There's one with a photon. This was his original image, which looks a lot worse, no offense to him, than the Feynman diagrams. And we also have a sine wave, which is actually pretty amazing, but it's actually a for loop. It's got that they actually have loops. It's somewhat powerful little language. But we'll go back to the text. Okay, the second window is their online editor. And yes, it's smart for LaTeX. Let me show you. I'm going to do something here that I shouldn't do. But you notice as I type, it's already looking for stuff. Like, hey, I can finish this by just choosing one of these. Oh, I want equation. Yeah, there I go. When I choose it, it not only puts a begin, it puts an end. So if I put F underscore T equals to acceleration underscore I times mass underscore J. There it is. Okay, but of course that's in the wrong place. Doesn't matter. It won't compile because I'm not inside the document. So anyways, it's a smart editor. It knows what you're wanting. If I need to search in it, it actually brings up a little editor search. This is not your browser search or anything. This is actually code in your browsers, probably written in Java or JavaScript that they've written to make this good. So if I wanted to do all the equations, oh no, I want to look at the actual equations. So I put a curly bracket. I can search for all the equations. There we go. Can do replace, that kind of stuff. So it is a full-blown little editor. I've found very rarely, with the exception of quotes that come from Word with those damn matching quotes up and down, are the ones that only things that cause trouble. I'm going to come back to this, but if you look then off to the side, I hit this button recompile. It's taking this code you see in the middle window, compiling that and running it, and you will see the result. Now I'm compiling the paper, not the proceedings. So you're going to see I'm getting a compiling error here right now because I actually have a problem that the compiler actually has a bug in it, and that comes from the Compton thing. So if I actually comment these out, comments are percent signs, which means these are in there but no longer there. I recompile that. It will come out that the Feynman diagrams are bombing in my procedures. Now, why that is, that's really hard. I'll probably have to send it to ShareLatex for their programs to figure out why that's happening. So, but you notice now it is compiling. Well, I'm sorry, that's wrong. When I click on the paper over here on the right-hand side, I click on paper. That's my paper only, not the proceedings. And it should only do, there it is, you notice. So there's the beautiful paper, all in the 2 columns. It's got the headings on it. It's got my name. It's got the volume, the page numbers. It's even got one side shorter than the other so that when it's printed, it looks okay. I think this is actually off. I need to fix that, but I know about that problem, but that's my problem. And you notice all these equations he has in there, and even some equations that are broken up on this side. And it keeps going down, keeps going down. This is his paper, and it has references. Now, it has a lot of references, but I haven't done his references. I only did one for this example. But you can see everything in there, including the Feynman diagram. You can see I've commented out except for the Feynman part. So the Feynman stuff is bombing on that, but that's not, don't worry about that. Unless you're doing Feynman diagrams, it's not going to happen to you. And it's okay. So if I look at this, let's take a look at what we have here. You notice there's a bunch of stuff with these percent signs. Percent signs will make something turn out not be code or text anymore, but it'll turn it gray, and that means it's no longer, it's there, but the compiler doesn't see it. It's as if it's not there. You do that to either comment something out because you want to test something, or you want to write a comment. So you can do that. You can say, Dave, rewrite this. I mean, you can do it right in there if you want, but of course, you can also comment what you're doing there. It's fine. Remember what I said before? Here we go. Keywords, gravity mass, Ray Gallucci. I got another one, so I put in here real quick. David D. Hilster. Since I type fast, it shouldn't be that big a deal. Address is equal to 123 Main Street. Fred at, no, I'm not typing fast, moose.com. Okay, and that's got those in there. So if I do that, it should come out now. If I recompile, come to the top here, I should see I'm going to be added. And not only that, no asterisk, don't need them. Look at that. Now it's Ray Gallucci and Dave D. Hilster, and we got our little asterisks. If I put another one in, we'll get another one. He lives on Mars, and he's gerbil at moose.com. Recompile. And again, you can see how fast this goes. Compiling. There it goes. Now it says Ray Gallucci, comma, Dave D. Hilster, and Robert D. Hilster. He gets 2 asterisks this time. Again, we don't have to do anything. We ain't got to do nothing. And so all this stuff is read by this command called make title. And that's where my programming came in. What it does is it actually doesn't see any of this stuff. It takes this stuff and makes a title out of it in all this format automatically. You can notice, you can imagine the code for this to make all these things happen, especially with addresses. I tried doing that on my own. I couldn't do it. I had to use theirs and just hack into theirs. So it's pretty tough. Then you see introduction, you see section, and they numbered sections. You can then go see, I think we have some subsections here. Yeah, here we go. We'll see a subsection. So a subsection, you come down here. Here are the equations. The Compton 01 equation. So you see the reference to the Compton 01 equation, and you see here's the equation with the thetas and the lambdas and all that. You notice again, there's the mathematical stuff in there that has, I want that to be a lambda. It's a mathematical symbol. I've got to put it between 2 dollar signs. As I go down here further, you can see more and more, blah, blah, blah. I'm going to search for subsection. There it is. So there's a subsection. So that's how a subsection works. It automatically creates the subsections for you. And the CNPS heading is, again, a way, if you have that, it will number them with the CNPS setting, but it will not register those in the table of contents. Can you imagine the size of the table of contents if we did every section, subsection, and subsection in the table of contents for every paper? We can do it, but we'd have to pay double the price because the size of the content would be bigger than what's going on with having the paper. So, okay, I think that's pretty much it. Now let's go to the bottom of it. You notice we keep just getting paper and subsections, et cetera, et cetera. There's a couple things at the bottom that are good. Acknowledgements, you notice here, I'll put that there. Acknowledgement. I just put the acknowledgements, but if I look at the paper here, I see acknowledgements and something there. So that puts it in there. References. It says the bibliography style. Don't change that. Okay, who's there? I'm going to come. Does somebody have a question? If you're not, could you guys mute your microphones? Because I'm in the middle of a share. I'd have to come out of the share to do that. So if you just join and you have your microphone, if you want to jump in, absolutely blast through me here. I'll let you know. But here you notice the back matter, they call it acknowledgements. You notice that the bibliography style is a file actually, and that file is the AI proc bibliography style, which is this file here. Don't touch it. But that's what this file is. Code for books and all kinds of stuff there. Don't touch it. That's what I'm saying. That's what that one does. Don't move this either. It says, oh, look, the bibliography file is AAA-paper1. That's what this is. So I have to go in here, or Ray needs to go in here, put all his bibliography stuff in there, and then anywhere you see a cite, let's go to our one cite in here. Cite, and you see right here. So we have a cite to R. Calkins problem with relativity. I come in here and I see right at the top R. Calkins problem with relativity. So if you cut and paste that, you put a cite, open curly brackets, close curly brackets, and put in that same name, nothing else. What'll happen is over here that will turn up on the right hand side. You'll see the references are Calkins and the name, the whole thing, and it does all that for you. You don't have to care about how it's formatted. We format it for you. Okay? So that's how that works. Now, if I want to see, in this case, paper 2, if I want to see how the proceedings are going, I can compile that proceedings. And that's really basically compiling the same thing I'm going to have in the proceedings. It's just going to have many more papers. And this has 2 papers in there already. And what you'll see here is a little bit different. You're going to see a table of contents. You notice can photons, blah, 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 explained by Ray Galucci, and it gives you the page number. Then it says Moose, Phlox, and McGillicuddy by David D. Hilster and Robert D. Hilster and David D. Hilster. I just threw another paper in there. Then you come down here, and it's on page 1. It gives the name Ray Galucci that you can see at the top. It's done there's the header and the footer. It's got the headers correctly, the page numbering, and then it ends there, goes to the next page, and voila, there's Moose, Phlox, and McGillicuddy. And this is another paper, and its references. It may be the same one, I just cut it down. And notice, an index. It indexed Ray Galucci. So if you want to index Ray Galucci, how do you do that? Well, that's done in paper 1. Let's go up here at the very top. You notice it says right up at the very top, there's a couple other things that you can edit. And one of them is you have my authors. Oh, where's the index? Before I start saying the wrong things. Oops. Okay, there it is. Okay. At the top, you see here, my title. You can put this title in there, and it actually goes in several places. My authors, and then you have fancy head. This fancy head is what goes at the top here. Often in these papers, we have a very long title that could not fit at the top of this paper. You notice this one here is on the right-hand side, you see R.D. Hilster and David D. Hilster, Moose, Phlox, and McGillicuddy. Well, let's say that's super long, like Ray's is, and you want to say Ray Galucci, photoparticle interactions. That's all I'm going to put. That's going to go at the top of the page. When I make this template, I'm going to try to make it much more common. I'm going to say, here, put this here, put this here. I haven't done that yet. So that's what that is. And you notice also in here, you have an index. That index is at the beginning of my paper. It goes comma, last name, comma, first name. Okay. And that is the way we're going to do it. Now you can also do it there's also a way to do sub ones. I think if I put this here, this is a sub index. Don't know how to do those, go to the help on site, and they do great explanations of indexes there. The help online is excellent. It's made for the average person. It's not made for programmers. So that's why you see over here this Ray Gallucci on page 1. There's also gravity, and it says from pages 1 to 9, light from pages 7 to 9. Why? Because I got light in numbers of pages here. So it's on pages 7, 8, 9. So if I go in here and say wavelength, I go back, whoops, after wavelength, I want to index it. I just go index and then wavelength, and it doesn't take the same name. You can put anything you want there. So if you want to make more elaborate. So I'll compile this again. Again, it's compiling on their server. Once it's compiled, then it sends back the PDF file, the entire thing. So it sends up that, and there's the entire thing. Oops, wrong place. That was the proceedings. See, what happened is I was in the papers here on the left-hand side, clicked on it, and this is only the paper. If I want to see the index, I got to click on proceedings and say recompile. Again, this is the code I've stolen and rewritten to try to work this way. I'm not sure anybody's doing it this way because I didn't find any proceedings stuff that worked well at all. So this is pretty unique to us. And there it is, wavelength, page 1. So there you go. So that means you can go through your whole thing and then index the heck out of it. Hey, if I put an index on every word, they're going to have to come read my paper. Well, we'll watch on that for you. Okay. I'm not sure I can show if there's anything else we want to see. Oh, I did want to show you one other thing, and that is books. I'm going to log out and go into, my dad and I pay our $15 a month for ShareLatex for our books, Particle of the Universe, and Gravity is not free. So let's look at what a book can do for you. Okay. So it's compiling right now, and this is a book. There's Dad's graphics, drawings, images. That's the way we've done it. It's not compiling because Dad's probably put some errors into that. Let's look at a book. Here's a title page. Gravity is not free. Is not free. If you go into this, you'll see Gravity is not free somewhere here. There it is. Book title. So this is a book, different. Subtitle of the book, Pushing Gravity Beyond the Apple, second edition. Authors, Robert Hills. You notice that again, I'm not formatting squat. It's doing this. Oh, and look at that. The John Chappell Natural Philosophy Society, a John Chappell Natural Philosophy Society publication. So this is because we have this system, we can generate and put there, publication, make books for people. Here's a book is dedicated, contributors, contents in brief. Didn't do it, just generated it by itself. Table of contents, here it is, generated completely by itself. There we go. List of figures by itself. List of tables, again, auto-generated. Forward, you have a forward area that you just type into and blah, blah, blah. Acknowledges, same things there. Then the preface, these things now, and then part 1. You notice books will have part 1. So if you look here, /part, curly bracket. Oh, part has a square bracket, huh? Interesting. Yeah, parts have square brackets because that's because it's added to the book. That's probably just a legacy thing of them writing the language and eventually doing books as well. So there you go. You can see all that. And books also have appendixes. So let's see if we can find some appendix. Oh, here's an interesting, I don't know if you can see it. That I did with the drawing, latex drawing. It looks like that's going to be foreverly big and huge, but it really isn't. One of the great things is you notice there's 2 arrows here. Go to the location in the PDF. Go to the location in the code. So sometimes they're good, sometimes they're not. Moon's orbital plane. Yeah, see, it's close but no cigar. Where's the moon's orbital plane? There it is. Okay, it's close. When you got 4,000 lines in the text, that's okay. So here you go. And I'm going to take a look at this one drawing, just to give you an example of how complicated it can be. So this is called Moon's orbital. Oops, not it. It's not that big. That's it. That's it for that entire drawing right next to here. That's pretty phenomenal, really. And yeah, I did a grid, and I'm going to show you the grid. So I'm going to recompile this and show you. So Dad, if you put these grids in, you can just copy them, that you see a grid somewhere. You make the grid the right size. I said 30 gray. Just keep everything the same. The only two numbers you want to change in the grid are the bottom left and the upper right, and that'll put the grid. So, oh, it's kind of like, there it is. See it? So there you go. There's the grid. And you notice that Earth, if I look at Earth here, let's see if I can find Earth. Okay. I made Earth the center of the universe. So
Hey, Dave,
almost.
I have a question.
Yeah.
That search drop down menu for search, where is that?
Control F.
Oh,
Find.
but there's no icon to click on.
No, that's a good question. I guess we're so used to that. Anywhere you go in a browser, if you do Control F for find, that's how it comes up.
Yeah, I've done that in Word, but it didn't occur to me here.
No, it's a very good question.
Thank you.
No, thank you. So you can see here that Earth is actually not at 0, 0. I don't know why that is. I think that's because, oh, that's the word Earth. Oh, of course it's not. It's at 0.08. So if you notice here, Earth, the little green guy, so if I search for green here, I made green. Yeah, there we go. Green is a, here it is. Here's the Earth circle. It's a green circle at 0, 0. Well, 0, 0, I made the origin here because everything else is around it, like curves and things like that. So that's what I did there. And then the Earth, then you can see the Earth is at y coordinate 0. It's in the same plane as x there. And then it's 0.8. So that means it's over 0.8. That's the center. It centers in the middle of the word. So that's how you can see there. But see, that's not a lot of code for what's there. It's pretty amazing. Yeah, it's tedious because you got to go over here and say, okay, 1 year, where do I put 1 year? It's minus 1, 2, 3, 4, 5, and it's up 1.2. So I should look for minus 5. Let's see, 1 year. See if I get that. And sure enough, it's minus 4.7, close to it, and then 1.2. That's what that grid is for. Again, Dad, if you want to draw again, just copy this grid line, just lock, stock, and barrel, and then change these two numbers. That's the lower left, so it's minus 7 at the lower left, and it's plus 5 plus 4, and of course the origin is included in there. So you have to do an origin calculation backwards. The way I look at this is the first coordinate is the coordinate away from the left side of the grid and the left bottom, and this is the right top, and that's the way I look at it, away from the origin. But if I again comment it out, put a little percent in front of that, then that grid goes away. I usually leave it there in the code. That way, if I want to draw it again, then I can.
Hey, Dave, my first drawing, I copied one of the simpler ones, not this one, obviously. And I saw that line, but I didn't know what it was. But I copied and started editing and trying and moving and
Yeah.
changing until I found out how some of these statements really worked. So I first copy you and then I screw it up by editing.
Yeah, no, that's okay. But now you see that grid, Dad. If you get that grid, it makes it so much easier to
Yeah,
find out
yeah.
where those things go close. And I sit there and tweak them. It just takes a lot of time. I put them in there, I tweak it, I move it. It's like it's a pain sometimes. And sometimes you don't know how to do something. How do you do you can rotate, for instance, if you want to take an how do you draw a partial arc that's rotated? Things like that. And you see here in this, you see a rotate of 24 degrees. So I've rotated, an ellipse, a partial ellipse, and I even have a function up here for partial ellipse. So I copy these. I go on the internet. I literally, you can go to Google and Google any of this. You can put TIKZ, TIKZ, partial ellipse, and you'll see somebody who had the same question, and you'll see an answer to it. So There you go. Motions of the moon. Look at that one. That's really small. But again, and the other thing I do too for those, let's see if I have this one here, Dad. Another thing I do just for a trick that I've used, see if this works here, is that I'll put the include graphics of the actual thing below it. So if I already have a graphics for it and I'm redrawing it using the ticks and latex, I'll go ahead and include that graphics in, and you'll see, yeah, there you go. See that, Dad? What I did is I've included the graphics in, and then I right above it, I start building it. So it gives me, I don't have to even look back at it. If I already have a drawing I'm trying to copy, that's what I do. Once I'm done and I have my grid and I've done everything right here, I then just take this, oops, and there you
Okay,
go. And that just,
I like the bottom one better.
yeah, if you like pixelation, yeah. I mean, that's a style. Pixelation is a style. Okay, that's it. I'm going to stay here. If anybody has any questions, I'm going to, well, actually, I'm going to get off of this. I can come back to this, okay? Okay, let's go back to, uh, all right, probably not. Wow, so there's only 6 people around? Ha! That's funny. Anybody, if you actually, you can come back to your computers, everybody. If there are no more questions, there's no problem of stopping it here.
I, I have a question. Why
Okay.
is it that the electrical engineer seems to be at the bottom of the human food chain? You keep
Because I'm
telling me.
jealous, because the truth is it's not.
I know.
They're actually some of the best that I've seen. Okay, Paulina has a question. Go ahead, Paulina. Do you have a, probably not, don't have a microphone. Go ahead. Okay. Is JNC payable, is a pay to publish? Right now it is. Oh, no, pay to publish. No, what I do, here's what I normally do. Very good question, Paulina. What we do is, um, to be truthful, people don't make money publishing this stuff. I mean, let's be honest. Um, what we do is, what I've done in the future, in the past, is I'll give you the monograph that was 2,000 pages by Barry Setterfield. I helped him with that. Um, if it involves a lot of work on our side, we pay myself or somebody to help you with getting it set up and getting it to be published. And he paid me a certain amount to do that. And it was just my time. I mean, I have, time is literally money with me. So, um, you know, right now, no. The way we do it is we provide membership with the ability to publish their stuff, and all we get out of it really is the ability. What I propose, and this is not um, something, Paulina, that we have a real answer yet, because our new directorate, which we got done voting for on the 2 days ago, we will have as part of our meeting what we will do with that. My suggestion would be, number one, we're not going to make money off of every book that's out there. We're not selling. I mean, most people are hard to give them away, and I'm not trying to criticize in any way. That's just the hard facts. So what happens is we provide the publishing, and when you look at the book, if you want to actually publish it, we usually use Lulu because it's easy to transition and get it onto um, um, Amazon. But what you end up with inside, at least in the cover, is the 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 JNPS is the publisher listed when you open the book, like right here. Here's the book we're doing, um, and that's where it's listed. Yeah, right here. So if you look at this, here's the page. Here's the beginning. See right there, it's got the John Chappell um, and its little label, and it says there, a John Chappell Natural Philosophy publication. So my feeling is right now we're not going to make money off of this. The CNPS makes money. It does make money off the proceedings. The proceedings is where we do make the money. I think we did a charge per page for Barry Sutterfield, and he chose to print it out and then give everybody a copy and that was under his own expense. He also paid me money to help um, uh, do that. See, latex may reduce the price per page then. No, the reason is that's the way we do make our money. I'll be honest with you, Pauline. There's two ways this organization, and I know for a fact because I've been involved with that more than anybody probably, is how do we make money? We make money from three things: membership, the conventions, conferences, and third, which is a big money maker, is the proceedings. And the reason is that we feel that we are the number one dissident proceedings publisher out there. And yes, it costs money. Um, and we have never refused a person's paper because they can't afford it. We've had people who couldn't afford anything and we've published it for them. But knowing that you have the n number of pages and you pay for that, that gives us the ability to function. So those three things: proceedings, conferences, and the memberships. Those are the things. The memberships, in my opinion, give us working capital for paying the video conferencing like this Fuse. It's almost 500 a year. No, the free versions, they don't exist anymore. They've been pretty much blown out. This is a great price for the great amount of people, and we use it a lot. And per member, when you have, we always have in between up to 100 paying members. Those at any time, um, that that helps pay for that, and that's a small amount. And this, and this ShareLatex, that's like $30 or $40 a month. But those are paid more by the membership. But no, we can't really reduce that price. And the 15 is actually a price you're paying as a premium to be in that more than anything. And the work that was done beforehand and not using this latex system, that was just it was horrendous. At that point, we were, if we had any types of monies that Greg and I, our time was just ridiculous. We did receive some money for that, but that's not the goal. Um, any other questions? Maybe not. So, okay. All right. She's got, yeah. Oh, and yes. Oh, there's another question. All right. We'll wait for Paulina. Hello, Robert Benner. Hey, Peters. How you doing, Peter? Good to see you. Peter, you're going to like our book. My dad and I are writing furiously. I compiled it. It's 185 pages. Okay, so
That's a very big book, and with color, it's even more ridiculous. Um,
I
so you
know, but
know,
Dad, don't worry about that, Dad. Dad's talking about the finances. He's not in charge of that. So
uh,
he's just a brilliant scientist. Please disregard any artistic or financial comments by my father. I'm sorry.
I inherited all my art talent from my son.
No, you didn't. Okay. Um, although I like your drawings, they're simple, but they make me think. Okay, the question from Paulina is, do scientists and amateurs join MPS in order to publish and present? Yes, that is true. We do guests. We have had guests, and we have no problem with that. If a person, for instance, is a scientist who may have maybe they don't want their associated with us for what obvious reasons, then yeah. And again, we're always open. If people are just destitute and they can't pay anything, of course we'll look into doing that. We have people who um, are not paying members who are writing blogs for us. But the reason is I don't push it is because we're not, beggars can't be choosy. If I have a person who's willing to write a blog, but it's just not, whatever. Most people do become the members and paid, but paid membership are for those people who really do support the organization, and knowing their paid memberships matter. But yes, you have to be a paid member. In fact, that's one of the ways we get probably a third of our memberships renewed is when we have our proceedings come out. When the proceedings come out, or we have voting like that, people will tend to pay up their memberships. But you have to remember what we do is we consider, at least in the old organization, I considered, it was my decision, that anybody who published in the last or was a member for the last 3 years, even though they're not paid up, are considered to be a member. Paying members have certain rights. Paying members have rights to I think Paula maybe has gone. Oh no, she's still there. But paying members have certain rights. You can only vote if you're a paying member. You can be, you don't have to be obviously a paying member to give a talk, but you can give talks. If you want to give a talk on your latest paper, that's great. That's a privilege. Also, you get a blog. We don't give blogs out. Like I said, I have some members that are considered to be guest members. Let's say James Maxlow, the premier expansionist on the planet Earth, which Wikipedia will take out of expanding Earth, the premier guy. But if he writes something, or I will even ask him, hey, you wrote this, can I publish that in a blog and put that on our site? So we encourage amateur, that's not even a question to us. We don't care what you're, obviously in the CNPS, we don't care if you're an amateur or professional or anything. All we care about is what you're writing and what you're presenting. So, any more questions? Okay. Appreciate the ability to comment or reply if there's an error or problem. Oh yeah, absolutely. With the website. Got one more question coming, I guess. So 2D Hillsters, 2 interim directors, Paulina, who's here a lot, Peter, who was at the conference, and Robert Bennett. Thanks for being here, Robert. Question is coming still, so I believe so. Is there a written standard for presentations? There's 2 types of presentations, and there's not a written standard, but I'd like to impose a written standard. Not in the content, but in the presentation itself. The EU people have really slick presentations. I'm not always convinced necessarily of their content, but that's a personal thing. But they do very well at making very nice presentations. But one of the things I'd like to do, we sort of impose in the sense that everybody who presents, almost everybody, with some exceptions, are required to have slides. And normally we do look at those slides ahead of time, or at least have to have those slides. But I would like to try to get a standard. And I think the way to do that is to actually use our Google account and have it so that all presentations that are given by CNPS members, either video and or in live ones, have our John Chappell Natural Philosophy Society logo at the bottom, and also maybe even have some sort of structural requirements like a title page. Most people do it, a title page, maybe a state your assumptions right up at front, things like that. I mean, it may be as simple as that, to have a um, title page, assumptions, that kind of thing, but structural, not content. We will not, the content will, the subject, yeah, we do actually have, that's been from the MPA when we were that, now we're the CNPS. The content is pretty simple. It has to be science related, and its main premise cannot support the existence of UFOs, of of um, conspiracies. We did reject one Yeah, no UFOs, no conspiracy theories. The reason we don't tackle that is because we feel our premise, at least it's been my premise, and I've sort of sold this to everybody. We have so much to work on in regular science. We just don't need to put that on top of it and then get distracted. Sort of like Bernie Sanders, my political hero guy. He's basically says, I'm not going to talk about Clinton's hair or what her husband did. I'm going to talk about the issues. So don't get me off message. And I think that's what we do. So we do have a statement. If you look, I think on our website, it will state that in fact, you can be inspired by a religion, by a philosophy, by UFOs. If you like UFOs, we've got people who believe in them, but they'll write science papers or, that kind of stuff, um, but not, the actual subject has to be scientific as well. One of the jokes I made in the MPA when we used to be the MPA was that I was going to write a very nice paper on baseball, even though I'm not a big baseball fan, because there wasn't anything that said I couldn't. And who's to say what the subject matter is? And that was just to point out that we need to do that. And we have rejected one paper. I remember specifically its main premise was to show that one of the buildings in the 9/11 came down by someone exploding it and we said, if you can remove the physics from it and it doesn't have anything to do with the conspiracy idea that this was blown up or not, then you're free to write it. And she goes, no, that's the main premise, and that says exactly what we reject things for, and we will. We have rejected that the science has been really bad. We had a couple incidents with the MPA with that. In fact, Dominus Spencer had and this one couple. It was pretty embarrassing what they were talking about. So yeah, we have some say on that. Any more questions? No. Thank you. Okay. All right,
Thank
then
you,
I will.
Dave.
Yeah.
I'll just say thank you, Dave.
Oh, well, thank you.
Uh,
Thanks so
you,
much.
I made some more notes from your presentation on drawings.
Yeah, absolutely. Take a look at that grid stuff. The two things, if you have a drawing already of it, put it below it, and then also make your grid, and it'll be much easier. So the only thing I don't have it, I love on that grid is and I'm going to talk to them. I'm going to try to convince these guys to put in some more stuff. But no, thank you everybody. And I will be stopping this recording. I will be downloading it and putting it to our channel today. So look for that in an hour or two.